Right, we have another teardown video for you. This time it's something I used to see lots of, but haven't seen recently for a while. A VCR. This one's very old, very falling apart. In the interest of speed, I've decided to dig out a cordless drill, and with any luck, should fit the screws. So let's start. I have a screw container, which I've carefully put over there where I can't reach it. There we go, much better. Switch it on to fast, and it should make this much quicker. Nothing but a steel case, and that can just go for scrap. As you see, there is a tape stuck in it. Anyone under the age of 30 won't remember that. Don't know what's on that tape, no idea. Midsummer Murders, oh god. I might do a separate teardown of that later, for those who haven't seen one. Right, these are usually latched with just plastic, yes, they are. Well, this one is rather. Polystyrene faceplate. Literally, faceplate is just plastic. There's a single spring up there, which I will have for my collection of parts. This is a later model VCR. There's lots of cables and connectors that can go in there. Yeah, as you can see, this is a later model because there are very few parts in it. The earlier VCRs had stacks of circuit boards in them. Take the deck out, if I can find the fixing points. All of them. Which I apparently can't. Oh yeah, there they are. Ah, this is a common... Nope, that's the wrong motor. What I'm trying to do is find the motor that operates this. Ah, there we go. Oh, that's typical. If I was keeping this VCR, I would obviously have used an extended screwdriver bit. Because I'm not, I just forced the screw out. This is the mechanical parts, aka the deck. Oops, we have a problem here. I probably need a number 0 screwdriver. There is a single screw stuck that was holding it. I'm sorry if you can't see, I've tried to angle the tape down a little. What, the tape? The camera down a little. Now, as you can see, there's not really a lot there. Rubber belt, very heavy flywheel on the pinch roller. They can actually be handy if you come across a VCR. Let me see if I can remove this. Yeah, this could be fun. There we go. There's the pinch roller. Actually, if I remove these screws, this is actually the pinch roller, that's the capstan. Sorry, I'm trying to hurry. To make this video shorter than some of my 45-minute ones. Lots of these screws do double duty as fixing screws and alignment screws. That is, I believe, the audio head. Yes, that's the audio and tracking head assembly. probably would have cost a fortune in its day. Not too badly worn. Oh yeah, it is. I was going to say it's not too badly worn, but I don't know whether you can see that. I don't know whether it will focus, but you can see the copper is worn out, or it's worn down to the copper rather. That can go over there. Now let's try to, there we go, remove this board. These motors, like this one, are related to the motors in computer fans. You can see there's dozens of little coils in there. See if I can remove this clip here. There we go. The flywheel itself has a magnet inside, and you can just see it's trying to grip that. There's not a lot of power to it. Yeah, it's managing to grip that. That is a ring magnet, and these hundreds, well not hundreds, dozens of poles are controlled by this driver chip. Sorry. They're controlled by this driver chip here. This here is a speed sensor. It picks up the magnetic field from the outside. I believe it's a Hall effect sensor. I could look them up, but I can't be bothered. Ugh, heatsink goo. That's obviously from the motor driver. It was stuck with heatsink compound to the metal. Quite clever design. But yes, that operates as a very accurate variable speed AC motor. These are handy if you're building your own gyroscopes. I may keep that. That, on the other hand, there's quite a bit of copper in there, but it's not worth scrapping. There's nothing on there except the driver chip, a diode, back protection diode probably, the Hall sensor, and a plug. So that can go there. VCRs, loads of cogs. This actually, the cog I've just ripped out there, if I put it back on momentarily, is actually quite a clever design. If you notice, when it reverses motion, it not only spins the motor, I might put that on back to front actually, yes, there we go. Yeah, it not only spins the motor, but it reverses the direction. See, if you put it that way, it's turning that reel. If you turn the motor the other way, it's turning the other reel. Quite clever. That spring-loaded bit there is just to hold it on. Steel. VCRs, lots of mechanics in them like this. Hundreds of tiny cogs like this. Absolutely useless. This is the head assembly. Now, still plugged in. There we go. As you can see, you hold the motor still, the head assembly spins, and you can see the path the tape took was a helical path around there. These are the individual heads. This is a 4-head VCR. Looks like it hasn't been cleaned since it was made. They are the gap in those is widely regarded as one of the most, or was widely regarded as one of the most accurately machined parts in the average home. I think it's in the order of millionths of a metre, micrometers. But that spins at the frame, is it the frame rate? I think yes, it's 60 rotations, it's 60 or 50 rotations a second, or well, 1500 or 1800 RPM, depending on whether you're in North America or somewhere that uses 50 Hertz. screw's not coming out. Quite interesting. It's very difficult if you can't get the screw out. It's very difficult to open this up. Let me see if I can, yeah, oh, just about, hold on. No, I need to get that screw out. Let me, you can see another one of those if I pull the circuit board off. It's another one of those motors. Same concept, ring magnet there. Hundreds of tiny coils of copper, or dozens of coils of copper. I keep saying hundreds. This bit stays still, this bit actually rotates, spinning the heads past the tape at several hundred RPM, several tens of hundreds of RPM, as I've said. Let me see if I can, yes, got the screw to start, that's good. How to remount the head of a screw in 10 seconds flat. There we go. That's the magnet assembly. Again, that's useless. Alright, let me see if I can... There we go. You can see the magnet's working quite well. It's picked up all the screws. These magnets are not really useful for anything, they're not strong enough on the edge. I'm sure you could use them as a generator if you were that way inclined. Oh no, I lied. No, this appears to be, if I can get it to come out, yep, it's magnetic strip. That could actually be useful. You can make your own fridge magnets or something if you wanted to. I don't. Let's steel again. I don't know if I can get this piece apart. It's hundreds of tiny Allen key type screws and they're all glued. In there is a load of electronics that measures the it's a rotating transformer that connects these heads, which are spinning, as you can see. It connects the heads, which are these little slots. I didn't point that out before, sorry. These heads are these slots. When you don't throw it, they connect, the transformer connects that to that, and there's also a speed sensor in there for the servo control. Keeps the speed accurate. Piece of circuit board, relatively useless. Right, all that's on here, these are the tape guides. These buggers are a bugger. I wonder if I can remove them actually. Yep. I have the correct screwdriver bit here, so if I align it properly. Oh great. Apparently that might be why this VCR was thrown out then. These are supposed to be threaded, or they were moderately. Nope. They're threaded there for adjustment on the end. There's not really a lot more in the mechanical section. What I want to do though, because I'm doing this not just as a teardown video, I'm doing it also to rescue the parts and dispose of my collection of out-of-date electronics. There's a tiny DC motor, not tiny, a small DC motor. It's even labelled plus and minus, very handy. Yeah, there's really nothing much else on here. Loads of screws if I could be bothered to remove them. Actually, there aren't that many screws. It's all riveted. It's because it's a late model. The earlier models would have had quite frankly hundreds of screws. You could probably get 900 or 1,000 screws out of a decent sized VCR. I keep them because they're screws in VCRs, even the late model ones like this, are a very odd thread. They are not Japanese, they're not metric rather, and they're not American thread. They are a special Japanese thread that nobody else knows anything about. There's another one of those steel rods. These are very handy. You can make studding out of them. You can even make screwdrivers out of them if you make a handle with epoxy resin of some kind. Not that anyone needs to these days, but it's always fun. This is the only bit that's interesting now, is this here, which is a perspex or plexiglass tube that comes up from the underside. This can actually go as scrap metal, even though it's got a lot of plastic attached. It will count as far as the dump is concerned as scrap steel. So all these bits won't, obviously. On the grounds they're not steel. There's a rather hefty spring. Handy beast. Right, I'll just pick up all the screws from this section of the disassembly. That's steel again. Not that many really, compared to the old VCRs. Oh, good grief. Pick up my screwdriver bits and yes, this does occasionally get swept up and dumped. Right, now back to the electronics. The little perspex or plexiglass cylinder I showed you connected to this LED here, which is an infrared LED, and what that did was it told the electronics of the VCR that there was in fact a tape in it. And you'll quite often find that they would go out of alignment or similar. I think that's all the screws. Yeah, I pretty much believe that's all the screws. If I can remove screws thus, might be a clip there, I can't see. These later one-board VCRs are quite boring, really, electronically. There's not a lot left to this video now. Right. Just bezels for the back covers. Even the case of this VCR isn't made of metal. It's covered in metal, but the actual structural parts are plastic. As you can see, rusty. It's been in the shed for a while. But yeah, this is all that's left of it now. This is obviously where the deck went. Vacuum fluorescent display on the front. You see you've got all your old long play, standard play, EP, SVHS, VHS, external link, record, enter, things like that. Timer, symbol. They work on the same principles as thermoionic valve or vacuum tube, but just at a much lower voltage. That's the metal clip that was causing problems. This, obviously being a European VCR, it doesn't have your, what are they called? The phono in-out, the RCA plugs. The only two it's got are for the audio, and I think they're just audio out, left and right obviously. There's your antenna in and out. They use the European or Australian standard connectors, which are not threaded. They're becoming a little bit rarer now, but most of the world uses the screw-on connectors. These are the two SCART sockets which take the place of all the RCA plugs that Americans use. Putting all the signals, audio, video, switching, data transfer, all in one connector was a brilliant idea. It's just a shame the French designed the connector, because it's shit. These plugs they are hated by everyone, I think. That was a little bit unfair. I don't think the French designed them on their own, but they certainly had a lot of input. And this actually may have been designed in Australia. And I'll tell you why I come to that conclusion in a second. This is the mains input, 240 volt. But down here, the connections are labelled N and A for neutral and active. Now the only people that I know of that call the live wire active are Australia and New Zealand, because I believe the Americans mostly call that the hot wire. Europeans, as far as I know, mostly call it live or phase, depending on what part of Europe they're from, and the Australians call it active. Interesting. Well, it's interesting to me. You can see it's a very early bit of surface mount. Most of the stuff is standard through-hole electronics on the back, single-sided board, hundreds of jumpers. You just don't see this these days. These are all wire links, crossing over a track. There's obviously a rail running up the back. There's a data bus running up the back there. So they've used these hundreds of links. It must be it's the data bus feeding. I don't know what it's doing actually. It's connecting several chips together and going to the vacuum fluorescent display. But yes, you can see they've used hundreds of jumpers to get over that. These days they'd use a double-sided board and just have the wiring this side going this way. But this was obviously cheaper. This is probably the mode switch. Famous part on old VCRs for going wrong. The VCR wouldn't know whether there was a tape in, whether the tape was threaded up, whether it was in fast forward. It would get confused, chew up the tape, half spit the tape out, and then refuse to do anything with flashy lights. If your VCR did that, quite often it was this little mode switch here. It just reacts to various movements of the deck. You can see it's got contacts under there, and a very complicated track arrangement there that makes and breaks lots of different connections. And all it takes is for one of those little wipers to bend one of these tracks to get some dirt on it, and the VCR thinks it's in record when it's in playback and records over the thing you've just rented from Blockbuster, which really didn't please them. But yes, this is the TV tuner. It's on a separate board, probably because various countries in Europe used various different frequencies. For example, the Irish used VHF TV a lot later than most of Europe. So an Irish VCR would have a different tuner to cater for VHF. There's some digital electronics on the back. It might actually just be an analog amplifier, I'm not sure. Looks like digital, but LA is probably an amplifier. Oh yes, these are the sensors. They're on two poles that went through holes in the side of the deck mechanism. Remember the plastic light pipe that came up? It would shine through there and there. And all these are, if I can... Oh, they've actually pulled the solder out of the circuit board. You couldn't do that if you tried. What they are, I might actually keep these. They're photodiodes, I believe. Or they might be phototransistors. All they are, they look very high-tech. It's a plastic moulded pillar with the actual component just stood up on legs in it. That picks up the infrared light. There's another one this side. S photo. That doesn't really tell me whether it's a photodiode or phototransistor. I can probably Google the part number, if I can find a part number, or I just do some measurements on it with a meter. It's not difficult, not high tech at all. But yes, as I was saying, sorry, the power supply, your fuse. I think these are these are high voltage bridging capacitors, because it's only a 2-wire connection to the mains. There's no ground, obviously, but you don't want this at low voltage side assuming a random voltage to ground, because that can cause all kinds of hum problems and buzzing, interference. It can even damage sensitive equipment that's plugged in. So they use these capacitors to bridge the isolation gap between the hot side, which is live at mains. You see on the corners, these are going probably to the they're going to the analog ground, which basically ties the analog ground to somewhere around half mains voltage, usually, but at a very high impedance. It sounds silly in Europe where it's 204, or in Britain where it was 240 volts, that would lock them to 120 volts on the chassis, which sounds a bit strange, but that's a very high impedance supply, and it's better to know that it's at 120 volts with very, very, very little current available, than to not know where the hell voltage is. But yeah, this is quite, sorry, I was saying this must be a crossover board, crossing over between the times when single-sided through-hole componentry was the norm, and some very early surface mount gear. There's a lot of surface mount transistors, a few surface mount diodes maybe. Yep, this is actually a very interesting example, because there's some through-hole resistors, very tiny ones, through-hole inductors. They were probably cheaper at the time than the surface mount inductors. There are diodes, Schottky diodes by the look of it, by the look of the symbol. And again, on this power supply, through-hole components are the norm. You can see what you've got here across the isolation gap barrier. There is an optocoupler. It's basically a photodiode in one end and an LED in the other end, or phototransistor, I'm not sure which. This is the sensor, by the way. Remember the tabs on the back of VCR cassettes, video cassettes? If I show you, where's the cassette? There. The little tab there. When the cassette was in, the tab clicked that switch. It is literally a switch. You see, broken it open. It's literally a pair of carbon-coated wires. They're graphite or carbon-coated to make them not oxidize. When it was pushed back, it made contact and said, yes, this is non-recordable. But yes, I believe that's pretty much all there is to say about this VCR. It's a very like I say, it's a crossover between the two technologies, because you've got some surface mount gear, not much, mostly through hole, very conventional circuitry in here, but switch mode power supply, and no big linear transformer. That's the transformer for the whole lot. A couple of chokes there. That's probably, I see one, that's probably the switch mode controller. Yep, very early switch mode controller. There's no multi-pin chip. It's a 5-pin IC package. I can probably look that up online. Oh, and these things here detect tiny magnets that are on the reels, so they know if the take-up reel isn't turning. It knows I must be eating the tape. Stop. They never actually bothered to stop until after they'd eaten the tape, but the thought was there. This is quite common in VCRs. It's single inline packages with custom parts. And this is a capacitor, apparently. Doesn't look like a capacitor, but apparently it is. It says C7. Very odd. And a couple of crystals. One there. Saw another one somewhere, probably on the back of the board or in... ah, yeah, there. No, that's about all there is to say about that, unfortunately. Quite boring, really. But it's got another thing out of my garage, so thank you very much for watching.